Hi everyone, my name is Sara. I'm a second year PhD student working in Olga Vitek's lab. So before starting, I like to know how many of you had experience working with Git before. All right, it's like half and a half. So what I want to do in this lecture is to briefly introduce what Git is and why we should use it. And then I will talk about what commit is and then how often we should commit and what we should basically write as our commit messages. And then I will introduce GitHub and what push and pull means. And then the second half of the lecture will be a practical small project that we will do together to basically practice what we learned here. And then after that, I will talk about R Markdown and briefly introduce it to you. So there might be a situation which many of you are familiar with. Let's say that you have written a paper and you think that the paper is final, so you name it final. But then it turns out that you need to make some modifications to the paper, so you will do that and name it something else like final new. And then this process may happen again and again, as you can see in the picture, which is the life of PhD students. So you will again rename it, and then this process can go many times. So what can go wrong is that after the paper is finalized, if 1 year passes and you want to go back and find your paper, you look into the folder and there are a lot of files all named final something, and you cannot find the really final version of the paper. So the possible solution for that is that you just name them like final 1, final 2, final 3. So then it's easy to find the really final version. But again, the disadvantage of this way of naming files or using this method is that you cannot keep track of the files. You cannot see what was the process of updating the paper and how you what changes you made to the paper so that you finally finalize it. So that is situation 1. And there is another situation in which so you're working on a project. Let's say you are coding, and then the project is in a good state, everything runs perfectly and everything is fine, and then you decide to make a huge change to the project, like write something complex or something like that, and then you will start changing the file. So what can go wrong in this situation is that the project can get messy. Like you're receiving lots of errors and you don't know how to solve them, and you wish if you could go back to the previous version of the file where everything was fine. But you cannot do that. So you can do Ctrl-Z like several times, but that's not really practical. So the possible solution is that you can always save a copy of the good state project somewhere, and the disadvantage is that, well, you have to do this several times because you're working on a huge project and you want to change it several times, let's say during the year, and this will also occupy a lot of space on your laptop, which is not good. And the last situation is when you want to work on the project with a teammate, and both of you are working on the same project, let's say the same file. So you make changes separately on your own computer, and the teammate also make changes separately on his own file. And then by the end of the day, you two have to sit together and say that, okay, I made these changes here in the file. He will say that I made those changes to the file, and then you have to manually update your code so that your code is updated to the changes that your teammate has made. So this is really frustrating. And that's the main reason people use GitHub, to be able to work in a team. So obviously the solution to avoid all of these situations is using Git and GitHub. Okay, so what is Git? Git is basically a software that you install locally on your computer, and you can handle version controlling of your files easily. And then by version control, I mean to take a snapshot of your files every time you edit them. So by doing that, your files will be updated to the latest version, and you have the ability to just go back to the previous version of the files whenever you need them. So it's easy to just look at the history and revert the file to the previous version. So this can solve problems in situation 1 and 2. And for situation 3, I will tell in a minute. And then a repository. What is a repository? Is that so whenever you start a project on your computer, all the project and the history of file is stored on the computer, and this is called a repository. So any questions? Okay. So what is commit? So every time you save your work, you can commit the changes to Git. And if you remember, Git was a software that you install it on your own system. So you can commit the changes to Git each time you make changes. And a commit is basically a snapshot of your files at a time point, specific time point. And commits create links to other commits in which you can see in the picture below, which shows different commits, and you can just go back and click on each of those circles and see the history of your file and easily revert your files to any commit step that you like. So that is about commit. So a question that may come up is that, like, how often should we commit? Is it like every time you make a single change, should you commit it to Git or not? So these things that I will tell you are just some good tips, and it's better to do them. But sometimes when you're busy and the deadline of the project is approaching, you may not have enough time to really focus on how to write your commits, and you will just write something. But these are good tips to just have in mind. So the commit should be minimal but also complete. By minimal, I mean that it should contain a single task. Like if you want to write a function, the commit should contain only the information about the function. Or if you want to draw a plot, you have to make the plot complete and then commit it. So if you want to discover a new problem, you should do a separate commit. And then the task that you are doing should be complete. Like you have to make sure that the function runs correctly, there is no error or bug in the function, and you have basically done whatever you are claiming to write as a commit message. And about the commit message should be concise, but on the other hand, evocative. Like if you look at your commit message, you should be able to understand what's going on just by a single glance. And on the other hand, it should also have enough details so you can remember what is going on in the project. And the other good tip is that just don't say that, okay, this is a plot of X versus Y, just say why you are committing this. So let's say let's say that, okay, this is a plot, that the scatter plot that shows the correlation between these two variables. So this is the reason of your committing, not the what is, like, by what I mean, don't write a plot of X versus Y. Say Y. Like, let's say this is a plot that shows the correlation between X and Y, so that you understand why you wrote that plot in your project. Okay, do you have any questions up to now? Okay. So all the things that I described up to now was happening locally on your computer. And now talking about GitHub, GitHub is basically a remote server. It's a server in which you can save your project and all the history of your project on GitHub, just the same as you have them on Git, so that you can access them both on Git and GitHub. And whenever you make changes on your own computer, you can commit them and then push them to GitHub. So this way, everything is stored both on your own laptop and also on GitHub server. And the advantage of doing that is that if something happens to your laptop, you will not lose your data, because everything is stored on GitHub server. And this will let you to work with a team easily, because your teammate can also push the changes to GitHub. You can also make some changes to the file and push them to GitHub. So everything will be on GitHub server. And you can easily access that. So here is this situation 3 which I was describing. Let's say that one is I, and I'm working on my local computer, and then this one is my teammate, which she's also working on her own computer, but we both are working on the same file. So I make changes on the project, I commit them locally on my Git, and then I push the changes to GitHub server. And now, when my teammate wants to start working on the project, what she has to do is she has to pull the changes from GitHub to update her files with the latest changes, and then make her own changes and commit them, and then push them to GitHub server. And again, whenever I want to work on the project, I have to pull the changes from GitHub to update my files locally on my own computer, and then push the changes back to GitHub. And this process should, you should do this like several times while doing working on the project. Do you have any question? Sure.
So I tried using GitHub for syncing my files between my desktop and my laptop.
Mm-hmm.
I was wondering if you can also do that with settings for RStudio.
Oh, yeah, we can do that.
Okay.
Yeah, we are talking about it today. Yeah. Any more questions? Okay. So we are about to begin our practical experience. So you have to all install Git, and there are instructions for how to do that. I will assume that you all have Git on your systems, and then I will do the practical example on my laptop. So first of all, you should create a GitHub account on the GitHub website. To do so, just type github.com and create a free GitHub account here. I have already done that. So here is my GitHub account, and here you can see the list of all repositories. For our project, I will create a new repository by clicking on the green button here. Okay, so let's do that. I will call my project my first Git try. And here you can write a description about the project that you want to work on. I will just write that I am trying to learn Git. The repository can be either public or private. If you want a private repository in which nobody can see what's going on in your repository, you have to choose a private repository. And for that, you have to pay GitHub to create a private repository for you. For our project, I will just select the public repository and everyone can see this repository. And finally, I will initialize this repository with a README, so click on that. This means that you will have a README file in which you can write some description about the project, and people who want to contribute with the project or other people from outside which see your GitHub page will understand what the project is about. So now go ahead and click on Create Repository. So my first Git try repository has been created for us. In order to clone the project into your RStudio, click on Clone or Download and copy the link provided here. Alright, so now let's open RStudio. We should create a new project. So click on File, then New Project. Okay, don't save the working directory. And then click on Version Control. So click on Git, which says clone a project from a Git repository, which is exactly what we want to do. Okay, here paste the URL you just copied. And then if you like, give a name to your project directory and then select where on your computer you want to save the project. I will save it under a folder named GitHub, in which I have created on my computer. And then click on Create Project. Oh, since I have already created that before, it says that this already exists. So I will just delete that and create it again. Okay, let's do it again. Click on File, New Project, don't save, and then Version Control, Git, paste the URL, and click on Create Project. Alright, so now the project has been created for us. Here under the Files tab, you will see the different files related to our project. Here is the README file we created on GitHub. If I click on that, you will see that my first message that was I'm trying to learn Git is here. You can also add other lines of message to this README file. So what we want to do is that we want to create an R script and just work on a small project together. So click on this small green plus button here and choose R script. Let's save it in the same folder that every other related files are there. So click on File, Save, and I will call this rproj and save it in my first Git try folder. Okay, here it is. So Now let's try to push and commit things to GitHub, to Git actually. The dataset that I want to work on is the iris dataset, which is a famous dataset. Let's look at the first few lines of this dataset. It is about the information of some species of flower, I think 4 species, and you can see information about sepal length, sepal width, petal length, and petal width. Let's say that we want to plot a scatter plot of the sepal length versus sepal width. And we want our plot to have a proper X label, Y label, and a title for the whole plot. So this is our goal, and if you remember, when I was talking about committing, I said that we should commit when the task is complete. So we should only commit the change to Git whenever our task of making a scatter plot is complete, which means that we have a scatter plot with proper X and Y label and a proper title. To do that, I will write plot X equal to iris sepal length, and then Y is equal to iris sepal width. Let's see that. Okay, perfect. So I'm not still ready to commit because still I have to add some labels to X and Y axis. Okay, so let's do that. xlab equal to sepal length and ylab equal to sepal width, and the main title is, let's say, a scatter plot. Alright, looks nice, and since this is what we were looking for, our small task here is completed and we are ready to commit. So we have to first save the file. You can see that the file here, the name appears in red, which means that the file is not saved. In order to save that, click on File and then Save. Now that the file is saved, we are ready to commit the changes to Git. So click on the small Git button here and choose Commit. Here you can see the list of all the files that are related to the project that we are working on. The changes all appear in this rproj.r file. So we have to choose that from the list of files here. So if you choose that, you will see the changes here which appeared on green color, which means that these lines of codes are added to the file. Here in this small window, we can write our commit message. So I will write a scatter plot of sepal length versus sepal width to see the correlation between them. Okay, and then click on commit. So our changes have successfully been committed to Git. So you can do this process again and again while working on the project, writing several lines of codes and then committing them to Git. After several commits, you may want to push everything to GitHub.
because you want to add all your changes on the GitHub server to have a second record of your project there. Since we don't have enough time, I will only do that first commit that you just saw, and I will assume that I have committed several lines of code, and now I'm ready to push everything to GitHub. Okay, so I will click on this Git icon again and then click on push branch. Okay, now everything is pushed to the GitHub server. To check that, let's go back to the GitHub website and let's refresh it. You can see that this rproj is appeared here and your first commit is here. So we have successfully committed our changes to GitHub. And clicking on this R file will show you the content inside the file. Alright, let's go back to RStudio. So now what we want to practice is a case where you have made some changes to the file, but later you regret the changes and you want to revert all of the changes to the previous commit. In other words, you want to revert everything to the previous stage of the project. So let's assume that I have written these two lines of code, like the correlation of the iris dataset, excluding the last line, because the last line is not numeric. Okay, let's see that. Okay, this gives us the correlation between all the variables or all the numeric variables in the iris dataset. And let's say we want to see the pairwise scatter plot between all the variables in iris dataset. So right here is the pairwise scatter plots. So now if I want to revert it to the previous version, all I can do is to just delete these two lines, but assume that you have a huge project and you have made changes in different places and you are receiving an error and you don't know why, and you just want to reverse everything to the previous stage of the project where everything was fine. So two situations may happen in this case. The first one is that you still have not committed the changes. If this is the case, then everything is really easy to revert. So let's say that I have saved that, so I just saved it, and then in order to revert things, you should just click on Git and then click on this revert our project. Before doing that, I will just copy these two lines of code. Okay, so let's revert the code. It says, are you sure you want to do that? You will say yes, and then as you can see, everything is reverted to the previous commit that we have made. So now assume that this time you have made some changes like this, and then you have saved that and you have committed those changes to Git. And then after committing, you will regret that and you want to go back to the previous commit or the previous stage of the project. So let's assume that I have committed that already, saying that the, let's say, pairwise scatter plot of variables in iris dataset. Okay, now if you want to revert the changes to the previous commit where these two lines of codes were not there, you have to click on the history icon here, and here you can see the history of your commits. So this can be longer than that, and if you click on that, you can go to different stages of the project, and for each commit there is a unique SHA ID. So this commit has the unique SHA ID of this, and then this also have a unique SHA ID. So just go back through the previous commits and choose the stage where you want to revert the project to that. Okay, so this is not what we want, and this is the stage that we want to revert our code to. So let's just copy the SHA ID here and then close this. To revert that, we have to type some lines of code into the terminal. So click on Tools and then Terminal and choose New Terminal. Okay, all you have to write is to write git checkout and then paste the SHA ID and then write the file name, which is rproj.r. and hit on enter. Okay, now the project is reverted to this commit stage with this unique SHA ID. So now we should commit that the file is reverted. So let's say revert to previous commit, then commit that and push it to GitHub. So let's check. Okay, we can see that it is successfully reverted to the previous commit on GitHub as well. So just do this practice over and over again for yourself. Write some lines of code, try to commit them and then push them to GitHub, or try to revert your unwanted codes to the previous stage of the project. Now at this point I want to talk about how you can work with collaborators on the project. Up to now you were the only person working on the project, so all you had to worry about was to committing and only pushing everything to GitHub. If you have a collaborator, the collaborator will also change the project, commit them on his own local repository, and then push the changes to GitHub. So in order to get each other's updates of the project, you have to pull the changes from GitHub to your own repository. So since we don't have any collaborator right now, I will assume that I am both myself and my collaborator. In order to add a collaborator to the project, you have to go to the GitHub website and then choose the project. Here you can see that this project has only one contributor, which is yourself. To add a collaborator, click on Settings, and here you can see an option for the collaborators. Click on that, and just type the email address or the GitHub username of your collaborator, and after doing that, an email will be sent to your collaborator, an invitation email, and he or she has to accept that. So let's go back to the project. I will assume that right now I am the collaborator in which is going to make some changes to the project and then commit them and push them to GitHub. So if the collaborator push the changes to GitHub, everything on GitHub should change, but you still will not have those changes here on your own repository unless you pull the changes from GitHub. Okay, so I will manually edit the file on GitHub and assume that the collaborator has pushed the changes to GitHub. So what I want to do is that I will assume that the collaborator is going to add this to the GitHub, which is petal.length, and the xlab is petal length, and I will commit it, and I will say that the histogram of petal length in iris dataset. Alright, so my collaborator commit and the updates appeared here on GitHub, but not on my own repository. So for me, in order to start working on the project, all I have to do is that, first of all, I have to pull branches from GitHub to make sure that my Git repository is updated to the latest version. So let's click on that. Okay, you will see that this line of code appears here. So now I know that, alright, this is the updated version of the project, the latest one. And now I'm able to work on the project. So I like to add another histogram here. Alright, let's save it. Then commit it. Choose our project here. Commit the histogram of sepal length in iris dataset. Right, now push it to GitHub. So if we go here, we will see that both lines of code is now available here. And there is no conflict and everything is fine. But in reality, this is not always the case. So your collaborator may start working on the project, and meanwhile you also start working, and you will just pull branches from GitHub, and then nothing will change here. So you will assume that, alright, there's no other change, and you will start working on the project. Meanwhile, your collaborator writes some lines of codes and push them to GitHub, and you don't know that. So you already have pulled the changes from GitHub, and since you don't know that, okay, some lines of codes are added here, you will also start adding things on the exact same lines of codes that your collaborator has already changed and pushed to GitHub. So now if you try to push the changes to GitHub, you will receive error because the Git will not understand what to do. Alright, there are two set of changes in the same line, and I don't know which one to pick. So you will receive a conflict error and you are responsible to solve that. Let's create a scenario like that. So let's say that it's now your turn and you have pulled changes from GitHub and it will tell you that already up to date and you are not worried about any changes. And meanwhile, your friend or your collaborator is making changes to the project. So let's say that the collaborator will add a box plot. Alright, and commit that. So you will also add something here, like summary of the iris dataset, and you will save that and commit that. Let's just simply write summary of iris data. Now you want to push the changes to GitHub, but since already on GitHub there is a box plot on the same line, you will receive a conflict error. So try to push it. It will say that okay, there is an error and it will suggest you to git pull before you pushing again. So let's pull. It will says that alright, we have auto merging problem. There's a conflict and you have to fix the conflicts and then commit the result. Git will show the merge conflict between these two lines of code. So this is the sign that you will always see as a sign of conflict. Above this equal signs is the lines of code that you have written, and below that is what your collaborator has written. So what you should do is to just look at these lines of code and decide what you should do. Should you keep both of them, or you should just keep one and delete the other? And this is just your responsibility to solve the conflict. So what I want to do is that I will decide to keep both of them. So I will delete these extra signs and keep both codes here. So now I have to save the file and commit and say that the conflict is solved. So let's do that. And push everything to the GitHub server. Okay, so if you look at the file, you will see that both lines of code is now here. So this was a case of working with a collaborator. Now assume that you are working on a project and suddenly in the middle of the project you have an idea and you want to do a lot of changes to the project and you just don't want to mess everything up in the same branch that everyone is working on. So what you want to do is that you want to create a separate branch and make some changes there, and when you are sure that your idea is working and everything is fine, then you want to merge the new branch back to the original branch where everyone was working on. This is called the branching in GitHub. So let's assume that now I want to create a new branch, and I want to add some codes there and then merge everything back to the main branch that I am working on right now. In order to see the list of all branches, just go to terminal again and type git branch. So you can see that right now I'm on the main branch, which is called branch master, and the color is green, which shows that I am on this specific branch. Let's create a new branch and call it branch 1. So write git checkout -b and the name of the branch, which is branch 1. So now I have switched to a new branch called branch 1. If I see the list of all available branch again, I can see that now I have two branches, branch 1 and branch master, and I am already on branch 1 because this is showed in a green color. So now that I'm on branch 1, let's add some codes to this branch. So I have already prepared some codes in order to just avoid typing a lot of codes here. Okay, so let's say that I want to just add a function called complex function, and then I want to print the result of that complex function given some inputs to the function. So let's save it and let's commit the changes to Git. So click on our project and then commit that. I will just write a silly commit message. Okay, so I have committed that. So if we want to push it, the changes to GitHub, we will see that the push and pull icons here are not active. To be able to push your changes to GitHub, you have to write a line of code here in terminal. I mean a command. So the command is easy. You have to write git push -u origin and the name of your branch, which is branch 1. Alright, now everything is pushed to GitHub. So let's go to GitHub website and update the project. So you will see that here you can see the list of the branches, and branch 1 was created like less than a minute ago. So you can switch between branch 1 and branch master. If you see the file on branch master, those lines of codes are not here. because we wrote them on branch 1. So let's go to branch 1, and you can see that those lines of codes are here. So now let's say that I want to add more things to this branch. So I want to call the deployer library and then group the iris dataset by species and then get the mean of sepal width for each species. Okay, so that is what I want to do, and then let's save it and commit it. Let's say group iris data by species and take mean of sepal width for each species. And let's push the changes to GitHub. So again, I have to type git push -u origin and the name of branch, which is branch 1. Alright, so let's check that again. Let's go to branch 1 and then look at this R project, and all the new changes to branch 1 are appeared here. And if we look at branch master, it still has no updates. So usually when you create a new branch, other team members will continue working on branch master, which is this one. So they will start adding some lines of codes to the master branch. And then when you want to merge everything back to the branch master, since there are some codes in the same lines of file, you will receive some merge conflict, and again you have to solve that. So for that, I will also add some changes to the master branch and then try to merge branch 1 with branch master. So here, let's switch to branch master. You can switch to different branches with the git checkout command. So if you type git checkout master, I will switch to branch master. So just look at here and see that this is changed after hitting enter. Okay, the reason is that I'm now on branch master, and this is the file in which it looked like in branch master. So let's again switch back to branch 1. Oh, sorry. Okay, now I'm on branch 1. And you can just switch between different branches with this git checkout branch. So what I want to do is that I want to go to branch master and I want to add something here. So I want to again write the library of deployer and then filter the iris data based on the Setusa species. Okay, so save that and then commit. Filter iris data by Setusa species. And push the changes to GitHub. Alright, so now on branch master we have these lines of codes, and then at line 8, 9, 10 you will see these updates, and then if you go to branch 1 at line 8, 9, 10 you will see something else, and then we also have some more changes to branch 1. So now we want to merge branch 1 with branch master. In order to do that, we have to first make sure that we are on branch master. We are, but just in case, let's switch to branch master. So git checkout master, and then we have to say, alright, git merge, and then write the name of the branch in which you want to merge with branch master. So we want to merge branch 1 with branch master. Alright, so the automatic merge failed because we have some conflicts and we have to save that. Just similar to working with a collaborator, the merge conflicts will be shown between these two lines of these two signs actually. So whatever is here above the equal signs are whatever was written in branch master, and whatever is below the line are whatever were written on branch 1. So now you have to carefully look at the code and try to solve the merge conflict, and then after solving that, just deleting the extra signs here and then commit and say that, alright, the branch merge conflict is solved. So looking carefully at these codes, we will see that, alright, 2 times the library of deployer was called, one on branch master and one on branch 1. So calling it once is enough. So just do it this one. And then you will see that, alright, so here we have called the library, here we have filtered the data, here we have the complex function, and then printing the result of the complex function, and then, alright, grouping the iris data set, which is fine. So I want to keep all of them, and I just want to delete this print, which is an extra and necessary to have in my file. So now I will delete the extra signs here. And now that the conflict is solved, I will save the file and I will commit and say that merge conflict solved. And push that. Alright, so now branch master is updated. So now on branch master, everything is updated and everything is merged and everything is alright. And on branch 1, everything is just similar to what it was on branch 1. And now that we have merged branch 1 with branch master, we no longer need branch 1. So we can just delete that. So to delete that, write git branch -d, which is for delete, and branch 1. So now branch 1 is deleted. So if you ask to see the list of all the branches available, you will only see branch master. You can also do that here by going to branches and then all branches and deleting branch 1. So now we only have one branch, which is the master branch. Alright, that's all we have for the GitHub section of this lecture, and now I will briefly introduce R Markdown to you and show you a template of R Markdown and some useful commands that you can use there. So in order to create an R Markdown file, you have to choose R Markdown from this plus icon here. Okay, needs some updates, so I hope it goes fast. Okay, so let's give a title to our R Markdown file. I will call it R Markdown practice, and I like to create a PDF file. And let's save it in the same folder as the rest of my projects are there. R Markdown practice. Okay, here it is. So I can make some changes to the file and do the same committing and pushing or pulling and do the same things with this file as well as my .r project, or I can do the same on the readme file. So let's see what is the result of running this R Markdown file. So to do that, just click on this neat button and it will create an output of a PDF output actually. So we can see that, alright, our file has a title, the name of the author, the date, and then it has some texts together with the some codes and the result of code. And you can see that here we have a plot written in R, and all of that is been written in R Markdown. So you can also add Python codes to this R Markdown, but what we want to discuss today is all just about R codes embedded in R Markdown. So if you want to write some codes in R, so just writing texts is easy. It's just like how you will write text in a LaTeX. In order to write R codes, all you have to do is that you have to click on File or Code and then choose Insert Chunk. So something will be created for you and in which between these two lines of backticks you have to write your code, and then if you click on this run current chunk you will see the result of the running code, just an internal result. Like before clicking on neat and run the whole file, you can just see the internal results of running the code in each chunk here easily. So now let's say that we have an R chunk and we want to see the result of the summary of cars, and cars is a data set. And here cars is just a name for the chunk that I have. So you can see that, all right, here is the code that I provided here, and you can see actually the code and the result of the code. And clicking on this green triangle, you can see the results also here. So now let's say that I'm only interested in seeing the result of the code, not the code itself. So sometimes you may have a lot of lines of code, let's say 20 lines of code, that you do not want to include that in your report. All you are interested in is just showing the result of the code in the report. So for that, you have to add an option to this R chunk called include. And if you set include equal to false, then the codes in the chunk will not be appeared in the output file, but the result of running the code, which is the result of running the summary of cars here in this case, will be appeared in the output file. So let's look at it again. Oh, sorry. So this include is for when the code and the result are both excluded from the output file. So here you will not see any code, neither any result. And why is that useful? Because you may want to use the result of whatever is inside this chunk into your future chunks. Let's say you want to create a variable or just call a library or something like that, but you don't want to show them in the output file, and you want to use the result of that variable or the function that you have written in your future chunks. So that's why you may be interested in adding an option to just prevent the code and result to be shown in the output file. The other option is called echo, which can be false or true. If you set it to false, it will prevent code to be shown in the output file, and it will only show the result. So if I run that, you will see that the line saying summary of cars is not here anymore, but you are still able to see the result of running that line of code in your output file. So that was the echo equal to false. The third thing I want to tell you is the option of results equal to hide. And as you can guess, this will hide the results, in which is the result of running the code, and it will only show the code, no result. So let's run that. So here we can see the code, summary of cars, but there is no output for that. And the last thing I like to discuss with you is that you can have plots. Like you can write plot of something and see a plot in the output of our Markdown file. But what you can also do is that you can change the width and height of the plot, or you can also add captions to the plot, which makes the plots nicer and look more professional. Doing that is so easy. So what you should do is that you should add an option called fig.width and set something for that, let's say 10, and then feed.height and set that equal to 10, and then to add a caption you have to choose feed.cap equal to something, which is, this is my caption. So let's run that. Okay, here is the plot of pressure, and since the plot was too big, it does not fit here, so it is here. So the width and height of the plot has changed, and there is a caption added to the plot. So in the file, in the PDF file I provided for you guys, and you can find that in the Google Drive, you can see a list of the resources that I provided for you to learn more about how to work with R Markdown. Also, all the steps of the GitHub project that we did together is also available there, and you can use that as well. Thank you.